A commitment to a safer, more secure tomorrow. That is the mission of the Mixed Oxide Fuel Fabrication Facility, or MOX facility, at the Savannah River site in Aiken, South Carolina. This facility will be instrumental in permanently removing excess weapon-grade plutonium from the United States nuclear stockpile. And as an added benefit, this material will be converted into fuel elements that will be used in commercial nuclear power plants to provide electricity for homes and businesses in the United States. In the year 2000, the United States and Russia signed an agreement to dispose of at least 34 metric tons of surplus weapon-grade plutonium each. The National Academy of Sciences was commissioned to study the different management and disposition options for these materials. The Academy recommended that both the United States and Russia pursue a long-term plutonium disposition program that would make the plutonium undesirable by an adversary as well as unusable. To implement this program in the United States, MOX technology was selected by the National Nuclear Security Administration, or NNSA, an agency of the Department of Energy. This proven technology has been in use in Europe for more than 35 years and in more than 30 reactors worldwide. The design of the MOX facility is based on Arev's Malox and La Hague facilities in France. However, that design has been changed to meet U.S. codes, standards, and regulatory requirements. To supply the MOX facility with plutonium oxide, a pit disassembly and conversion process will take apart plutonium pits, which are a key component of nuclear weapons, and then convert the material into plutonium oxide. The waste solidification building, currently under construction, will process waste streams from the MOX facility for final disposition and disposal. In 1999, DOE signed a contract with a consortium, now called CB&I Areva MOX Services, LLC, to design, build, operate, and deactivate the MOX facility. MOX Services is owned by a U.S. subsidiary of CB&I, one of the world's largest engineering and construction companies, and Areva, a global leader in nuclear technology. Congress mandated that the facility would be licensed and regulated by the U.S. Nuclear Regulatory Commission. After conducting thorough reviews of the MOX design, the NRC issued in 2005 a construction authorization for the facility, the first such authorization in more than 20 years. In 2010, the NRC released its final safety evaluation report on the MOX facility. The Commission concluded that the design and operation of the MOX facility will pose no undue risks to worker and public health and safety. This represents a significant milestone in the licensing process. MOX is also regulated by the Occupational Safety and Health Administration to assure safe and healthful working conditions for every project team member. In fact, the project has achieved OSHA's Voluntary Protection Program status, which recognizes excellence in managing and promoting worksite safety and health. A closer look at MOX facility operations will demonstrate the safe conversion of plutonium into MOX fuel assemblies. Two major processes will occur in the completed facility: aqueous polishing and fuel fabrication. Aqueous polishing is a 5-level chemical process in which plutonium powder is converted to a liquid form and then purified to remove byproducts such as gallium, americium, and uranium. The purified plutonium liquid is then converted back to a powdered oxide form that is packaged in cans and stored until it is needed. The second process, fuel fabrication, is a 3-level mechanical assembly process in which fuel is produced just like uranium fuel that is used in commercial reactors throughout the United States. However, because of the plutonium content, MOX fuel fabrication occurs in glove boxes, which allows access to the machinery while protecting the worker. During the fabrication process, plutonium and uranium oxide powders are mixed to a desired blend and pressed into pellets about the size of a pencil eraser. When operational, the MOX facility will produce more than 70,000 of these pellets daily. To strengthen and increase their density, the pellets are sintered or baked in a furnace. The pellets are then ground to within a few microns of their required diameter and sorted by means of a fully automated system. Then samples of the pellets are checked to verify their dimensions, density, markings, and color. Fuel rods are manufactured by arranging the finished pellets in a long tray and inserting them into a zirconium alloy tube. Each fuel rod contains approximately 360 pellets. An end plug is inserted into the open end and the rod is welded shut. The rods are then cleaned and decontaminated and arranged on trays to be stored. The rods are assembled in a metallic structure to produce a fuel assembly. A typical fuel assembly contains 264 fuel rods in a 17 by 17 array, is 13 feet in length, and weighs about 1,500 pounds. The MOX facility will be capable of producing a wide variety of fuel types to meet the needs of both current and future reactor designs in the United States. One MOX fuel assembly can provide enough energy to power nearly 9,000 homes for an entire year. In 2008, 4 MOX fuel assemblies successfully finished 2 complete fuel cycles in a U.S. commercial power reactor. Since construction began in 2007, the MOX project team has achieved several major milestones by installing significant quantities of reinforced concrete, reinforcing steel, complex nuclear process tanks, piping, HVAC ducts, cable trays, and coatings in the MOX process building. Today, more than 4,000 people across the United States work in support of the MOX project, including contracts with U.S. small businesses that account for close to $900 million. When operational, the facility will employ between 800 to 1,000 employees, with operations expected to continue well into the 2030s. The MOX facility's mission to eliminate surplus weapons-grade plutonium is complemented by its overall commitment to energy efficiency, environmental stewardship, and support for small business. As NNSA continues implementation of the nation's plutonium disposition program, the MOX facility will play a key role in safely and securely removing excess nuclear material from national inventories in accordance with the U.S. international agreements for the disposition of excess weapons-grade material. The Mixed Oxide Fuel Fabrication Facility at the Savannah River Site, a leader in America's nuclear non-proliferation program.